Welcome back to our Advanced Kubernetes Management with Flux course. This is the fourth lesson, and during this lesson we are going to start to talk about infrastructure, and we're going to define our infrastructure by code. It is highly recommended that you don't go to the web console of your cloud provider and start configuring stuff from the web. It's highly recommended that you use some kind of infrastructure as code technology to define your cloud provider infrastructure. And in this course, we're going to use Terraform. Although Terraform is no longer open source, so we are going to use Tofu as our infrastructure as code, which is similar to Terraform, and most of the code that we show here can be run in Terraform as well. The thing is, when we're talking about advanced Kubernetes management, you usually would use a cloud provider. So we have to combine infrastructure and how you work with the cloud provider when we're talking about advanced Kubernetes stuff. So it is important that we touch about the cloud infrastructure. And it is important that we touch about the cloud infrastructure by using some kind of infrastructure as code technology. So we are going to talk about in this lesson about how we use those infrastructure technology, that infrastructure as code. In our example, OpenTofu, we're going to show how we can use that infrastructure as code technology to install Flux. So in the first lesson, we installed Flux using the Flux CLI. In this lesson, we will show a different way to install Flux using infrastructure as code. Now, while installing with Flux CLI, installing Flux in your Kubernetes cluster is a good solution. Often you're working with more than one cluster. Maybe you have a cluster for different environments. Maybe you have a cluster for production and staging and dev. Maybe you have a cluster for your continuous integration. So when the company grows, usually it manages more than one cluster. Then it will be very counterintuitive, hard to track if you install on multiple clusters, on many clusters using the Flux CLI. And then it's highly recommended to use infrastructure as code technology. So this is what we're going to focus in this lesson, how to install Flux using infrastructure as code, using Tofu. Now, this is going to be a very simplistic lesson. It's not going to focus on best practices. We're going to create very minimal stuff in order to create and install Flux. Later in this course, we will transition to infrastructure as code to be a bit more professional and a bit more while focusing on best practices. So again, our entire lesson is in the Academy site. So you have a step-by-step guide in the Academy site about everything we are doing in this lesson. In addition, all the code is in our repository, GitHub by WAREZK, Academy's K8 Academy's Kubernetes Flux. The code example is in here, and the infrastructure as code that is going to be in the infrastructure as code IAC folder. So in here you will find the infrastructure code example that we show today. Now we are going to show the infrastructure as code using OpenTofu, as we mentioned, OpenTofu, and we're going to use GCP as a cloud provider. Feel free, if you want this example in other cloud provider, feel free to raise an issue or raise a discussion. And if a lot of other developers will vote for that issue to create an example for another cloud provider or with another technology, not Terraform or OpenTofu, then we'll create this lesson in that technology as well. The main idea of Academy is it's non-profit, open source, and community driven. So you can drive what you want using the repository here. Also, if you can star this repository, it will be much appreciated, since it will gain traction and more users will open discussion and issues and write what they want to see in this course. So let's start talking about installing Flux using infrastructure as code technology. Let's recap what we learned in the previous lesson. In the previous lesson, we talked about a Flux operator that is called the Helm controller. And we talked about 3 custom resources that Flux installed on our cluster. One custom resource is called the Helm repository. The source controller of Flux is watching for this custom resource, and when it finds this custom resource, it will synchronize with a Helm repository. So this is the Helm repository. It helps us grab artifacts from a Helm repository. And we also learn about the Helm chart. The Helm chart is a custom resource, again, Flux installed in our cluster, that the Helm controller is watching for this custom resource. And when it finds this custom resource, it synchronizes with a Helm chart that is located in a certain Helm repository. So it synchronizes, we can tell them that we want to grab certain versions, certain updates. So this is the Helm chart. And we also learned about a custom resource called the Helm release. The Helm release is connected to a Helm chart, and it's going to manage installations, Helm releases of that Helm chart. So this is another custom resource that Flux provides us, that the Helm controller is watching for this custom resource. And when it finds this custom resource, the Helm controller knows that it needs to install a Helm release and manage updates for that Helm release. And we use this knowledge of Helm repository, Helm chart, Helm release to install something that we almost in every cluster that we're going to manage, we're going to install an ingress controller. And in this course, we focused on the most popular ingress controller, which is the Nginx ingress controller. So we use the Helm repository, Helm chart, Helm release to install the Nginx ingress controller. And this was in the previous lesson. So in our site, you can go to the Helm controller to the previous lesson if you want a quick recap of what we discussed in the previous lesson, get the video, the source code, and everything in the Academy site. So here's the plan for this lesson. In this lesson, we will start defining our GCP, our Google Cloud infrastructure with OpenTofu. Once again, if you want the same examples shown in a different cloud providers, feel free to start a discussion in the course GitHub repository. But I think the most important thing is not which cloud provider we're demonstrating on. The similar concepts apply to different cloud providers. It's more important to understand the concept than the actual implementation in a certain specific cloud provider. So we'll show things in Google Cloud Provider, but the important thing here is the concept, and you can try and implement the same concepts in a different cloud provider. And we'll show how to do those things with OpenTofu, which is similar to Terraform. And again, I don't think the focus is on the technology. You can use other infrastructure as code technology. There are many out there that are good. The concepts are more important. Defining your infrastructure in code is more important. Just choose a good popular technology, and you can also use OpenTofu like we're doing here. And if you want the same examples in a different technology, make sure to start a discussion in the course repo. And if there's a lot of other people that support that discussion, we will do a similar lesson with another technology. So what we're going to cover is, first of all, it is important to define your infrastructure with an infrastructure as code technology. So it is important to do so, and we'll discuss about the advantages of defining by code how your cloud infrastructure looks like. In general, I do believe that you don't use the web console that the cloud provider gives you. You use it just to watch the resources. You don't use it to create and change the state of your cloud. You just use it as a log, as a reading tool, as a way to read what you open in your cloud, not necessarily to create stuff in open. This, I think, you need to use some kind of infrastructure as code technology. So we'll discuss the importance of using an infrastructure and code technology. We're going to create a GCP project, a Google Cloud project, and that project is like an organizational unit where we're going to place all the resources that we open during this course. We are going to place them in a project. So we're going to open a GCP project. And then in that project, we need some kind of networking for our Kubernetes. So we are going to create a virtual network, a VPC, and we're going to create subnets. And we're going to explain a bit what is important when you're creating those networking resources for your cluster. We are then going to create our Kubernetes cluster. A managed Kubernetes cluster in Google Cloud is called the managed Kubernetes cluster. It's a service called GKE. And we're going to use this managed Google Cloud service to create our Kubernetes cluster. And then in that cluster, we're going to install Flux, but we're not going to use the Flux CLI like in the first lesson. We're going to install with OpenTofu, with Terraform, we're going to install Flux on our cluster. So this is the plan for this lesson. As we mentioned, the cloud provider we are going to use in our course is GCP. But bear in mind, we do not advocate for any certain cloud provider. We do not say that one cloud provider is better than another. And the focus is on not on the cloud provider, but on the concepts we'll be talking, because the same can be applied on different cloud provider. So GCP stands for Google Cloud Platform. As we said, we're not advocating for any cloud provider. Basically, we use GCP, and we're using open source technology in academies in general. But we do not say that Google Cloud Provider is better than AWS or Azure. If watchers of this course want to see the same example in a different cloud provider, so we'll do the same lesson in a different cloud provider if enough people request it and raise an issue and a discussion in our course repository. And the infrastructure as code technology we're about to use is OpenTofu, which basically is they forked Terraform, and because Terraform stopped being open source, and they have the same, basically the same syntax, the same code of Terraform, and probably the same code can be taken and be applied in Terraform as well. So when you hear OpenTofu, you can implement it in Terraform if you're using Terraform. Again, the focus is not on the technology. It is important for us to use an open source technology. This is why we chose Tofu. But you can choose a different technology. The main thing is the concept, not the technology that we're using. The main thing is to define your infrastructure with an infrastructure as code technology. So we'll be using Tofu. You can run the same code as we mentioned in Terraform. We highly recommend infrastructure as code technology, but we don't advocate for a certain technology. So if enough people raise an issue, we'll do the same implementation in a different technology. So if you want to see that, and make sure to raise a discussion or an issue in the course repository. And a few things why it's important to use infrastructure as code technology. So I highly recommend not to use the web. The cloud provider usually supply like a web console that you can use to open resources, and so don't use that to open resources. Use some kind of infrastructure as code technology. You'll gain a few benefits from using infrastructure as code. You'll gain, for example, consistency. So I can write a configuration, and I can have consistent configuration across different environments. If I do it manual from the web, there's a good chance I will have a human error and maybe, I don't know, open my Kubernetes cluster different in different environments. That might be a bit trouble at the future. We have automation. We can use the infrastructure as code in an automatic way, which avoid human error. You can integrate it in the CI/CD. It's easier to scale, so everything is in code. To scale, you can simply change a configuration in your code, and you can easily scale your Kubernetes cluster. There is repeating configuration, which you can use. For example, in Terraform, you can use modules for repeating configuration. Later, this lesson is not going to focus on good practices in infrastructure as code. This lesson focuses on simplicity. So we'll just open a simple resources to create a Kubernetes cluster and install Flux Provider on this cluster. Really minimal lesson about infrastructure as code. The next lesson, we're going to combine our infrastructure as code project with Terragrunt, and then we'll show how to manage correctly those multiple environments. We're going to work with multiple environments during this course to try to mimic the real life behavior. Usually, in the real world, you don't work with Minikube in your app, right? So we do want to show this course with real cloud provider resources. So we're going to show in the next lesson how to manage your infrastructure as code properly. So we're going to avoid repeating configuration. We have testing tools for infrastructure and code and linting tools. You can collaborate on your changes. So you can show a team member the configuration changes in the infrastructure that you want to create. You can issue a PR. Other developers can see the changes that you made in your infrastructure. Disaster recovery, right? So if something happens and you have to recreate your cluster, recreate your project, recreate your network, everything is configured by code. So you just run your code again, and it can be integrated as part of your CI/CD. So your CI/CD can actually automatically open resources, change configuration, run tests on the configuration. So there's a lot of benefits in the infrastructure as code. I think for me, the way that I can see the changes in the infrastructure, that I can easily control configuration, that I can work with the team is probably the most important feature of infrastructure as code. But once you get the hang of infrastructure as code, you won't use the web console, you only use infrastructure as code. You'll get addicted to this way of managing your cloud infrastructure. So make sure to work with infrastructure as code technology. Again, we're not advocating for Tofu or Terraform. We will be using Tofu in this lesson, but just the fact that you're using an infrastructure as code technology has tons of benefits. So Terraform by itself don't have a lot of power. To give Terraform more power, to give Terraform power to create cloud resources, we have to tell Terraform to install a provider. Think of a provider as a plugin that gives Terraform more power to do something. So for example, we now will use the Google provider to give Terraform the power to create Google GCP resources. So let's install Google Provider, and what a Terraform provider is, it gives Terraform the ability, it's like a plugin that gives Terraform the ability to create resources in a certain cloud or create certain resources in a certain place. The Google Provider will help Terraform create resources in GCP. AWS has a provider, Azure has a provider, Flux has a provider, so it's not necessarily a cloud provider. It also can be, for example, Flux Provider can install Flux in a Kubernetes cluster. You can have Postgres provider. So provider basically is a plugin that gives Tofu or Terraform extra power to create something. And when you look at resource, a provider helps Terraform create resource. So let's see an example. For example, I have this resource for creating a GCP project. So the GCP resources, in general, the resources usually start with a name, for example, Google, and then underscore, and then something else. And the first part of the name is usually the default alias name for the provider you're going to use. So even with very minimal configuration, Terraform will know, based on the name of the resource, to look for a provider that is named Google. And then it will use that provider. And look at this, at the block here, you didn't actually supply a provider, because what Terraform did, it looked at the name and then knew it need to use a provider that is the name of the provider, the alias name of that provider is Google. So this is the default behavior of looking at the name and figuring out which provider Terraform needs to use. So the resource name has a significant regarding the name of the provider to use. And some providers require additional configurations. So what we'll do in this lesson, we'll use the Google provider. The Google provider doesn't really need additional configuration, but you can configure it, for example, to create in a certain region, in a default region, or create in a default project. So you can give certain configuration to the Google provider, but those in Google provider, they're optional. We are also going to use in this lesson the Flux provider. The Flux provider, when we configure that provider, we'll see that we actually have to give that provider additional configuration. The Flux provider will get configuration about the cluster which we want to install Flux in, and also configuration about the repository that we're going to use. But for some providers need that configuration, some those configurations are optional. What we're going to use is we'll use the Google provider to create GCP resources. And the way you do in Terraform, it is important to define the providers that you are going to use and the versions of those providers. Since we're declarative here, it is important that the entire team members that sharing this project will work with the same provider and the same version of that provider. So for Terraform to use the provider with the versions that we want, we usually configure Terraform and using the Terraform block and provide in that block the required providers block, which we can specify which providers we want to use and which versions for those providers. We can also supply a location to download those providers, or we can have our own providers with our own location. And we can specify the version of a provider. And this is located in the Terraform block, and we can supply additional configuration for Terraform as well. And usually what you either create that Terraform providers block in a providers TF file or in a versions file. So let's create the providers TF file and specify there that we want to use the Google provider and we want that Google provider to work with a certain version. So let's create the Tofu providers that we need for Tofu to install resources on the Google GCP cloud. So I open the repository with my IDE. And I'll create a new folder called Infrastructure and Code, IAC, and in here we'll place all the infrastructure as code that we have. And here I'm going to create another folder that we'll name GCP. Now, if you want this example to be shown in a different cloud provider, for example, AWS, then raise a discussion in the course repository. And if a lot of people vote for it, we'll open another folder beside GCP for AWS. Remember that Academy's courses are community driven, they're open source, so you can vote, as you can suggest, you can raise issues if some of the content you think should be better or should be added. So feel free to comment and open a discussion in the course repository. So I created a folder called GCP, and inside this folder I'll create another folder called Tofu. Now, again, the same remark, if you want a different infrastructure as code technology, for example, you want the same example shown in Pulumi, so vote for it, open a discussion, and if a lot of people support it, we'll create that example as well. In the Tofu, let's create a providers file. So I'll open a providers.tf file. And in here, what we're going to do is we are going to create a Terraform block to configure Terraform, and we're going to say that we want one thing that I like to specify is which Tofu version do I require all the developers to use. So I don't want one developer to use Tofu version really low and one developer to use. I want them to all use in general a similar version. So I'll create, I will say that the version, I think the latest version, we can check what that is. The latest version of Tofu. And we can specify this version. So the latest version at the time of this recording is 1.8.4. So this is semantic versioning. So we'll say that we want 1.8. So this letter here, the tilde with greater sign, means that the rightmost number, the number 8 here, if I specify 1.84.4, for example, the latest, so it will take the rightmost number, which is, this is the major, the minor, and the patch. And it will say the rightmost number can be increased. So it can be like 1.8.5, 1.8.10, but only the rightmost. So this cannot be increased. But if I do this, I remove this. So basically I'm saying the rightmost number is the minor now. So I can add 1.8, 1.9, 1.10, but not major update. So I like to specify this. So I will specify also the required providers, and I will specify a Google block, and I will say that the version of the Google provider, notice that the name here doesn't have to be Google, but it's highly recommended that it will be similar to the resources that you want to create, Google. If Terraform will see that this resource starts with Google, and you will see you have a provider that is under the block of Google, it will know to match the provider with this resource. Otherwise, you will have to supply in this block, you will have to supply provider, the name of the provider to use for this block. So it's best to keep as Google. So now let's see what is the latest the latest Google provider. The version is 6.8.0. So we'll do the same trick as before. We'll say I want the version to be greater than 6.8 in the minor part of the version. So it can be 6.8, but it cannot be a major update. So this is the providers file. Later we will install Flux and we'll add another provider here to install Flux. Now let's open this this folder. So I'll open this Tofu folder with my integrated terminal, and I will do a Tofu init. And we'll see that it starts bringing the provider. So it's looking for Google. It found a matching version 6.8, and it finds it installed in the, if you don't specify here the host to install from, we'll go to default to the HashiCorp Google. It found a 6.8.0 and it installed this provider, and OpenTofu has been successfully initialized. Now, in here, it will supply a Terraform lock, which basically says all the providers and version and things we installed. So it specifies in the Terraform lock, and it installed the provider in the Terraform folder here. So usually you include the Terraform lock and the provider, but you place in a git ignore the Terraform here. So let's do this. Let's do git ignore for the folder Terraform here. So I will place git ignore for the folder Terraform, and see that now all we have is a git ignore, Terraform lock, and providers. Great. This is our required providers, the plugin that we installed for Tofu to be able to install resources in our GCP cloud. Okay, so we managed to create a providers file where we can specify the Terraform providers that we need to be installed in order to run our Terraform code. So now let's talk about, we're going to create the project resource in GCP. Now, to create resources in GCP, Google has released a project called terraform-google-modules, and we'll strive whenever we can to use the modules from this project. So terraform-google-modules is a collection of Terraform modules, and it's created by Google. So it's highly maintained while following best practices, and it really gives you tools to easily create resources in the GCP cloud. Now, the objective is to simplify the process of deploying and managing Google Cloud resources. So basically, you create resources using Google modules and Google guides, how to do it properly. And these modules provide reusable, standardized configuration, and they are maintaining Google's recommendation regarding best practices. And they are also flexible and customizable, and we will use those resources to create our GCP. We will use, those modules, those Terraform Google modules, to help us create GCP resources, like creating project. We'll soon create GKE, our Kubernetes cluster, networking, and more. So we'll soon use the Terraform Google modules, and think of it like there's not one module, it's a collection of many modules, and we will soon use the project factory, which is part of the Terraform Google modules project. So those projects are hosted under github.com, Terraform Google modules, and in here you have different modules. So we'll soon use the project factory to create a project. Now, basically what it does, it gives you a Terraform or Tofu module. You place a name, and then you place the source with which you place Terraform Google modules, and what modules you want to create. It's highly recommended that you tie it to a certain version, like they did in this example. And then it gives you basically the best practices you need to create a project. Well, if you want, you can create shared VPC, helps you with shared VPC, helps you with project services and more. So it's really, it's highly recommended to use the Terraform Google modules whenever it's possible. So in order for Terraform or OpenTofu to create resources in our cloud, we're using a provider. In our case, we're creating in the Google Cloud, so we use the Google provider. But that provider needs to authenticate with the cloud in order to create those resources. So that provider needs to authenticate under a certain user or a certain service account that has enough permissions to create those resources in order to actually work. So Terraform is using provider to create cloud resources, as we talked about, and each provider has different instructions regarding how that provider is authenticating with its cloud. So the Google provider might authenticate in a certain way, AWS provider needs to authenticate in another way. What you need to do is go to the documentation of the provider that you're using, in our case, it's Google provider, and read how that provider is authenticating with the cloud. So open your browser, look for Google Provider docs or Terraform Google Provider docs. And in the documentation, I'll place a link also in the description, you'll find a section about how the provider can authenticate with its cloud. Now, one of the things they will write, you can run gcloud. Gcloud is the GCP CLI. You can run a gcloud, so you have to install it. I think you can install it with Homebrew. So you run a gcloud command to authenticate. Now, we will authenticate in this lesson using the command gcloud auth application default login, but it is not the best practice and it's not the recommended way to authenticate, to use this as the means of authenticating Terraform or OpenTofu, the Google provider, with your cloud. This is not the best practice way, and we'll show how to authenticate properly by using a service account and impersonation and using something a bit more declarative than a CLI command. CLI commands are not declarative, and something that will run automatically every time you do Terraform apply or Tofu apply. But we'll talk about this in the next lesson, where we're going to arrange your code in a bit better, a bit best practice way. This lesson is focusing on simplicity, just talk about resources and creating those resources, and we're not focusing on best practices. So in the next lesson, we are actually going to authenticate in a different way, a better way. But for now, let's just use, if you read the docs, they say you can authenticate by simply running the gcloud auth application default login. So let's take this command and, and let's go and paste it in our terminal. Now, what this command is going to do, it's going to open a browser, and then using this, using the browser, you will need to authenticate. So you need to choose your account, you need to choose and enter your username, your email, and password. So let's take a few seconds to authenticate using this screen, and then after we finish authenticating, let's create the GCP project. So now that our Tofu is authenticated with GCP, we can start creating resources in our GCP cloud. The first resource we're going to create is a GCP project. Now, a project is an organizational unit in the Google Cloud, where you can open resources in that project, open VMs, open Kubernetes clusters, open networks. That project is connected to a billing account, meaning it is connected to a credit card. So you really can easily see what your project is spending. So you can understand the cost of, see your different project and see which one is spending what. And you can also track the cost of each project. Now, each project also create isolations. For example, you often place the staging and production in different projects. It also allows you help with the permissions. So you can set one developer to have permission on a certain project and doesn't have permission on a different project. So it helps you with permission, and you can limit the budget. So this is a mistake I did in the early stages of working with the cloud provider. I often did some kind of mistake, and then I saw the price that I had to pay that month went skyrocketed due to some mistake that I made. I'm sure a lot of people make those mistakes. So project allows you to place a budget. This means limit the amount that you can spend on a project. So I can say, okay, I'm opening a project, but I'm only willing to spend $30 on this project. And GCP also gives you alerts, so you can subscribe to get alerted when you reach 50% of the budget, 75% of the budget. You can get an email whenever you're close to reaching your budget. So what we're going to do is we're going to try to create a GCP project. Now, the way we're going to do it is using the Terraform Google modules, and inside this, there is a module called Project Factory. We'll try to use this Project Factory to create a GCP project. Okay, so let's create a main.tf file in the Tofu folder. So I'll create a new file. I'll name it main.tf. And what I am going to do is I am going to create a module that I'm going to call project. And in here, I'm going to place that module to be the source, to be Terraform Google Module Project Factory Google. So let's copy this. And I'll also want to copy the versions, right? So I want the version to be the latest version and the rightmost to be updated. So not major update, but I can accept minor update. So I'll place two numbers. And the latest, I think it's 17, like in this example, but let's verify, it should be on top. So the latest is 17.0.0. So I'll place it so I can get updated 17.1.2, everything on the right side, but not a major update. So this is great. Let's see a few options that we have here. We're going to have to activate some APIs, but let's leave it for now. We'll probably get an error later on, and then we'll activate that account. It's going to create in a project. It's automatically creating VPC network and subnets. So I don't want to auto create network. So I'll set this as false. Now the project ID, let's name this Academy's Kubernetes Flux, right? Like the name of our repository. So it's GitHub Academy's K8S Flux. So this is like the name of the repository, and we are going to connect it. We have to connect it to a billing account. Now the billing account, it's different in my GCP, so I'll place it in a var billing account. I'll create a variable for it. So I'll create also a variable files. And in here, I will create a variable named billing account. And the description is the GCP billing account that is connected to the project. And the type would be a string. So great, this is our variable. I will populate this variable by creating a terraform.tf vars file. And I will add this file in the git ignore. Just because I don't want to expose those values that I place here. So I will later populate this and place here a billing account and place some value here before I do a tofu apply. But I don't want to expose this, but you will have to provide a Terraform TF vars with your own billing account. So let's go back to the main file. So I set the billing account to be as a variable. You have to provide the organization ID. This again, I will create a variable for this as well. Okay, and I'll also hide this value and place a value after this behind the scenes. I don't want to be taping this. Okay, so let's go back. What other options we have? Let's see, bucket project, the project page is here in bucket name is for Terraform state. Okay, later we'll see when we talk about in the next lesson, when we talk about best practices, we'll store the Terraform, the tofu state inside the GCP bucket. But this we'll talk about in the next lesson when we focus on best practices. For now, we're just going to create the resources and we won't mind the state. We just place it in git ignore and place the state locally. Let's see, what other options do I have? Let's set a budget. I want the budget to be, let's say $30, and the budget currency will be US dollars. That's the default one. Let's see what other things I have here. You can place it in a folder, which is another organizational unit, but it's not connected to a billing account. We'll simplify things for now. You have to supply a name. I don't think you have to supply project ID. You just need to supply a name. Project ID will be created for you. You see that the error is gone, so we provided everything that we need. Let's create also, add random project ID, set it to true. If you set a random project ID, so the ID will be some kind of randomized string, then your the name. Otherwise, it will error out if I already use this name. So it will create some kind of random string in the name. I saw here a create project service account. When you create a project, by default, this module will create a service account for that project. Let's set this to false. Is it Boolean? I don't remember. Yeah, it's Boolean. Create, and I think this is enough for now. Oh, sorry. That's enough for now. Let's. I will populate the variables. So I need to populate org ID, and I'll populate the billing account. And then we'll try to run this and see if our project is created. Okay, so I filled in the missing variables, which we have billing account and organization ID, org ID. I created a file called terraform TF vars that can populate those variables, and I placed a value for org ID and billing account. I'm going to also add another value, which I forgot, is deletion policy set to abandon. What this means is that by default, we won't be allowed to delete a project unless the deletion policy is set to something different than the default. Now, when I set it to abandon, it means that I can delete this project. So let's try to run tofu plan to see what tofu, the same commands, by the way, you can run with Terraform plan to see what is going to be created. So always follow very rigidly what is going to be created. So it's going to create a project surface. We didn't supply it, but this is the default value of opening the API of a service called compute-google-apis.com. Create a random project ID. We set that random project ID to true. And the default service account is disabled because we set the, where is it? This one, create project service account to false. And also we are creating here the project, and we are going to create a budget. And the budget is going to be set to 30, and it's going to be assigned to this is the data of the project, which we will probably, for best practices, we're not going to focus on best practices, but you have this data from the Google project. You can probably output some of the data if you're creating a module. So this is what we're going to create. So let's hit tofu apply and see if it works. Try to do yes, and then see if our project is going to be created. So it's a good thing that it's loading for a while. It should take a while to create all those resources. So I think at this point we're gonna pause. We're gonna fast track to the end of this creation and continue after it finished to create all the project resources. Okay, so we managed to create the project, but during the tofu apply that we ran, the project was indeed created, but it had problem creating the budget for our project. And to activate the budget, I had to activate a few APIs, and also I had to place configuration for the Google provider. Now, usually I don't authenticate tofu the way I did in this lesson. Usually I create impersonation. So I impersonate the service account, and that service account is running is authenticating to create everything that Terraform needs. So usually I don't use this way, and this caused a bit of problems. So I had to give a few configuration to the Google provider. One of them is the user project override set to true, which allows me to change the default billing project that is set, that the Terraform is configured to use when you authenticate, and use something that specifically I mentioned here, which is the project that we created here. So if you authenticate this way, you might need to provide those things. After we do impersonation and authenticate with impersonating a service account, this will probably not be needed. So we managed to create the GCP project, and now let's talk about network and create the networking that we will use to later place in that networking our Kubernetes cluster. Let's talk about networking and start creating a simple network to place our Kubernetes cluster in that network. And to do this, we're going to create something called VPC. VPC represents a virtual network. It's not like your computers are connected, they're virtually connected. So you create a virtual network, and that your resources doesn't have to be in a certain location, right? The VPC is not associated to a region or zone. So that private network is inside your cloud provider, and it can be in different regions, right? So depending where your region is placing servers, your servers can be in different regions, and they're all connected in your VPC. So your VPC is like a network where you control what's coming in, what's coming out of the network. You control the firewall rules, and create isolation. So a lot of the time, the simple network architecture, you might have a single VPC to place all your web application resources inside a single VPC. And you might duplicate that VPC if you have multiple environments. So maybe the staging, dev, test environments, maybe your CI, they will have their different VPC, but your entire, what the users see, the entire server and interactions are in a single VPC. Of course, you can have a more complex networking architecture if you have microservices and maybe a lot of microservices and a lot of teams. Sometimes you will split your VPC you have many VPCs and you have interconnectivity between those VPC. But in our course, we'll keep things simple. We'll have a single VPC for each environment. So every resources we have in production will sit in a single VPC. And it allows you to define also network firewall rules, and it allows internal communication between the resources, the computers in your virtual network. They can communicate between themselves and between Google API and services. And another thing, range, think of it like a block in your VPC, is something called subnet. Subnet is a range of IP addresses in your VPC. Consider it like a certain location inside your VPC. For example, a subnet might be a subnet that contains your Kubernetes cluster. You might have a subnet that relates to database resources, cache resources, so you can split your VPC to sections, and those subnets can allow you to create further isolation, further firewall rules, subnets are associated to a region. So VPC, our virtual network, we said is not associated to a region. So one computer in your VPC can be in the US, one computer in your VPC can be in Asia. But a subnet is associated with a region. That doesn't mean that everything inside a subnet has to be in the same zone, right? So you can have a region in the US Central and you have multiple zones. So your service for our Kubernetes cluster, we will have it in a subnet in a region, but in production, that Kubernetes cluster will be regional, will be spread across different locations, different zones. So a region is a location, but that region is separated to different zones. So it's associated to a region, not to a zone. So resources in a subnet can still be in different location, but it's not like they're in US and Europe. The same location will be in US Central, different zone in US Central. And what we're going to do now is we're going to create a VPC and subnet to host our Kubernetes cluster. Now, one thing when we need to remember when we create VPC and subnets is regarding the IP addresses. So VPC has, a subnet has a range of IP addresses, and we need to make sure that our Kubernetes cluster has enough IP addresses. So in Kubernetes cluster, IP address is given to a node, given to a service, and given to a pod. And we need to make sure that all of them, and remember the nodes and the pods, they can scale, and the services might grow as your application grows, but they do not scale. But the pods and the nodes can scale. So if you have like a lot of traffic, you might have your nodes might increase and your pods might increase. It's something you need to consider when you're creating VPC and subnet. Do I divide the IP addresses correctly? And we'll touch on it a bit when we create the VPC and subnet now. So let's try and create VPC and subnet to host our Kubernetes cluster. So let's create our network, and to create our network, we're going to once again use the Terraform Google modules. So, but this time we're going to use the network. So we're going to use the Terraform Google modules network. Let's copy this example, at least the start of it, and the subnets here. Okay, let's close this for a second. So we're using the Google Network module. So we specify the source here. We bind it to a version, and we're allowing the miner to be greater than 9.3. 9.3 is the latest version. We place this VPC in the project we created. So let's do a module.project.project ID. Now we need to name our network. So this will be the network of our course. So we might as well name it like the name of our course, Academy's Kubernetes Flux. Now the routing mode, if you set to globals, mean it's global routing, meaning you can place, you can have place in different regions. So routing between your the resources in the VPC can span across multiple regions. They don't have to be regional and stay in the same region. So it's best if you're not sure where your crowd are coming, if they're coming from different locations around the globe, it's best to keep it global and allow yourself to span across different regions if you need. So in here now, we're going to specify the subnets. Now let's see how a subnet looks. A subnet looks like this. For now, we're going to create a single subnet, and that subnet name is going to host our Kubernetes cluster. So let's name it Kubernetes, so we know it's hosting the Kubernetes cluster. And now we need to decide a subnet is a range of IPs. So you can decide, you need to place here a seeder block from the private IPs sections. So let's say, so an IP, each one of those numbers is 8 bits, is a byte, right? So each one can range from 0 to 255. And so let's start with the private ID of 10000. And the seeder, the last part means that the first 24 bits, what I write here is, if I write 8, so the first 8 bits, this is constant, is fixed, needs to be 10, and those can change. Meaning you have 32, because it's 8, 8, 8, 8, it's 32 bits, the IP address. So the first 8 are fixed, meaning you can play with the last 24 bits. So the amount of addresses you have here is 2 power 24, 2 in the power of 24. So as long as this number is bigger, the amount of addresses you have is lower. So if I have, for example, 24, then all of those are fixed. The first 24 bits, which are the 3 numbers, are fixed. And the last one can change, meaning you have 255 addresses available. Now this is going to represent our nodes. So I think 255 is enough to represent our nodes. And a subnet is connected to a region. So right now it doesn't really matter what region what we choose. Let's say, I don't remember which, let's say US Central 1. So you need to choose from a different regions of GCP. Now, after this, we're going to specify secondary range. So a subnet, this is not only the IPs that a subnet can have. A subnet can have additional IPs with a secondary range. So we can specify secondary range. So this will represent the nodes. So we have up to 255 nodes. And now we're going to specify secondary range for our, what's the syntax of that? I don't remember. For our name of the subnet, which is Kubernetes. So we have another, and then we specify here, we specify different ranges. So the range name here, this is for the nodes. So we have up to 255 nodes. This is for the pods. For the pods, I want maybe a bit more. Maybe I want 2 bytes for the pods. So in here, I can specify a secondary range of 10, let's say 1, because I want it in a different group from this. I don't want them to collide. And I want starting from 0.0, and I'm allowing here the 16 first bytes are fixed, this and this are fixed. This can change, meaning I have 2 power of 16 pods that I can place. And let's say, let's place another secondary range. So I'll add another one, and this will be for the services. So services, we don't need a lot of services. So let's say we have, depending on how much your app, remember the pods can scale and the nodes can scale. So you have 255 nodes at maximum, so it won't scale more. So the pods can't scale more than this, this amount. But the services, I can keep in the group of, keep it like the nodes with a bit less, only this can change, only 255 IPs for the services. And I think that's about it. Let's close this. And this is our network configuration. Now let's try to create this. So I'll do a tofu plan. So I have to install the module, right? So I need to do tofu init. And now let's do tofu plan. Great. So I'm adding two stuff. One is a network. This is the name of the network. And I'm also creating a subnet for that network. And the subnet has this range and also a secondary range of pods, secondary range of services. Let's do a tofu apply. Yes. Great. Our network and subnets are now created. So we have a network for our web application, and we have a subnet in that network that we can place our Kubernetes cluster in that subnet. So let's create our Kubernetes cluster. During this course, we are working with a managed Kubernetes cluster. In GCP, the managed Kubernetes service is called GKE, that stands for Google Kubernetes Engine. And in general, it's highly recommended to use a managed Kubernetes service. The cloud providers offer you managed Kubernetes service, which offers a lot of things: managed control plane, high availability of the control plane, which means the control plane will be spread across different zones. You have logs, you have help with scaling, you have help with updates, things that will be very hard to implement yourself. So it's highly recommended to use a managed Kubernetes cluster, and we'll use during this course the GKE. After you create the cluster in GKE, you want your kubectl to connect to the GKE. So you can run kubectl commands, and it will connect to the cluster that we're creating now. And to do this, you need to authenticate your kubectl with your cluster. We call it context. Enter your kubectl into the context of the right cluster that you wanted to manage. And usually the way you do it, you place the authentication configuration inside kubeconfig. But luckily, we don't have to worry too much about kubeconfig, because usually the cloud providers gives you a CLI, and that CLI you can authenticate your kubectl with your cluster, and it will populate your kubeconfig details. So you don't have to worry about the kubeconfig file, but we need to run a command after we create the cluster. We need to run a gcloud command, or if you're a different cloud, use the cloud CLI. Find the command that you need to connect your kubectl to the cluster you just created. And kubectl, we are going to identify with the cluster we are creating. So we need to set a new kubectl context, and cloud provider CLI will help you with the command to modify that context. And after you run that command, the command in gcloud is gcloud container clusters get credentials, your cluster name, which we're about to create a cluster, then we'll choose a name, the region of that cluster, and the project that this cluster belongs to. So after you run this command, your kubectl can talk with the cluster you created. What we're going to do now is we are going to create a GKE Kubernetes cluster and connect it to our kubectl and run a kubectl command to see that we managed to connect to our cluster. So let's create our managed Kubernetes cluster. For this, we're going to use, once again, we're going to use the Terraform Google-modules. This time we're going to use the Kubernetes engine, their module for creating managed Kubernetes cluster. And so let's copy some of this code. We're going to copy this and the source. We are going to tie it to version. I see they didn't tie it to version in their example. So let's see what's the latest version. 33.1.0 is the latest version. So let's tie it to 33.1. Great. So let's see a few configurations that we have. We're not going to focus on a lot of things here. We do have the next lesson when we talk about best practices, and we'll focus on important configurations here. For example, in staging, you might do some things to save you the cost. For example, your cluster might be zone and not regional, and in production it will be regional. So we'll talk about those stuff next lesson. You might choose reserved instances, you might choose preemptible or spot instances to save location. You might change you might change the region as well, different costs in different regions. So you might place the cluster and staging in a different region to save cost. We'll talk about those things in the next lesson. We're not going to focus now. What we want is just a simple cluster. So let's specify a cluster need to belong to a project. You have to specify project ID. It's best to tie it to our module project. Why is not completing? Project name. Project ID, sorry. Great, so we tying it to a project. We need to name it. So let's name it like the name of our course, Academy's Kubernetes Flux. And we need to place it in a region. And we need the same region that we choose for the subnet. So our subnet is located in the US Central. We better keep it the same region, otherwise it's going to be problematic to use that subnet. You need to specify in zones. If your cluster is, you need to specify one zone. If your cluster is zone, if your cluster is regional, it's best to specify multiple zones. So let's take their example here. Great. We need to say which network, which VPC network this cluster is going to be part of. So this is the network we created above. So we'll enter the module VPC network name. We need to specify the subnetworks and the IP range pod and IP range services of that subnetwork. So let's specify those three options. They're getting strings, and they are the strings that we specified when we specified the network. So the subnetwork is the subnetwork name. It's the name we placed in the subnets here, the Kubernetes. We called it Kubernetes. And the secondary range, we called it pods and services. But once again, it's best not to hard code strings like they did here. It's best if you can use it from your module network output. It's a bit better. So let's take this and change the hard constant strings. Instead of subnetwork, I want this to be Kubernetes, but I don't want to hard code this string. Rather, I want to take this string from here. In case I want to change something here, it will be propagated in the Kubernetes cluster. So but I don't quite know where this value is in this module. So what I like to do is I like to open the Tofu console. The same thing can apply in Terraform console, and I can do a module.vpc, start typing code. It's like REPL only for Terraform or Tofu. So this, I want to take the name I have here from. I have here a list of subnet names, so I can take module VPC subnet names, and I can type it here just to verify subnet names. Subnet module VPC. Don't I have subnet names? Subnet regions, subnet names. Is this part of something bigger? Network ID, you have subnets. Did I type it wrong? Oh, I typed it probably wrong somewhere. Maybe I missed the S, subnets. Anyway, it's subnet names 0, so I'm taking this value, I'm playing with the value with Tofu console, and then I can just place those values here. Now I need the name of the secondary range for pods. So in here we have subnet secondary ranges. And in here, 0 dot range name will give me pods, and 0 1 will give me services. So these are the values for those two options. Great, IP range pod services. We're not going to touch on the other things. Maybe we'll touch a bit about node pools. So let's create the node pools as well. So the nodes that you have in your cluster, they belong to node pools. So a node pool is like a group of nodes, and you can have multiple groups. And you can place on each group, you can place the label. For example, you might have a group for maybe you have you need high computational resources, nodes with high computational power to calculate something cryptographic things or graphic things, and you might have other nodes that can serve your REST server. And then you can have two groups, one high computational and one simple group for your connecting to the database and giving data from your database in a REST server or whatever protocol you're using. So you can have different groups, you can label them, you can then in your deployments, you can say, I want 5 pods, I want 3 on this group and 2 on this group. You can really play with those groups. We'll keep it simple. In this lesson, we'll create a single node pool, let's say with three instances. So I'll name this the default node pool, and I'll create machine type medium. It's good. I'll place it in node location. This is the list of zones those machine can be, and they can be in all our zones. So let's place this. Great. They can be min count of 1, max count, let's say 10. We can say that it starts with an initial node count of, let's say, 3. I think that's enough. There's a few interesting things here, like spot instances, which saves costs, preemptible, which service account. But for now, for this simple example, I think it's enough. Let's try to run our code. So I'll do exit the console and do a tofu plan. Okay, so I got an error. It tried to reach a service called container-google-apis.com. So it needs this service enabled in order to actually perform what we're doing here, creating a cluster. So let's go to the project, go to activate APIs, and activate this API. Let's do tofu. We might need to do, before we actually do this, maybe we'll comment this for a second, just create our enable that service. Okay, so one to change is a bit weird, is want to change something in the budget. Sometimes it happens in Terraform where it looks in a certain value in a budget, and you need to tell them to ignore this value in order to not see this as a change every time. Currently I don't remember how to do it, but for now it's okay. Probably gonna not change anything, so let's keep it as is. And it's also enabling the project services container-google-apis.com. Let's hit yes. Great, it enabled it. Now let's uncomment this and try to run our code again. Seven to add, so this is a suffix, it's not some random letters, and this is service account, so it's creating a service account, a default service account. There are a few things that relate to metadata and logging, and those are the node services, metric writer. There's a few things that it's creating for us regarding metadata and logs, creating the node pools we created, and anything else that we need to check here. And it's creating the container cluster, or GK cluster. So great, I'm quite pleased with this. So I'll do yes, did I want to create? Give it a few seconds to actually create our cluster, and hopefully it will finish without errors. And when we created a simple managed Kubernetes cluster using Tofu or Terraform. So it finally did manage to create my managed Kubernetes cluster. I did had a few problems. So I accidentally had this as 0 in the IP range of services instead of 1. So I basically selected the same range of IPs for pods and services instead of this range of IPs for the pods and this range of IPs for the services. So that was fixed. In addition, another problem I had, it couldn't create my my instance group without giving the group of these permissions here. Only after I added this, it allowed me to create this group, which makes sense because in the context of a managed Kubernetes, they do provide us logging and monitoring, so it does make sense to add those permission to the node group that you're creating here. After I did this, it managed to create my Kubernetes cluster. So now what I want to do is I want to authenticate my kubectl with my newly created cluster. And the way I do it is by updating a file called kubeconfig. But usually you do not need to update that file manually because the Cloud CLI provides you with a command to authenticate with the cluster, and then it will update the kubeconfig file. And GCP Cloud has a CLI called gcloud. So AWS, it's a different command, and Azure, it's a different command. But in here, gcloud container cluster get credentials. So let's run this command. And I need to supply the name of the cluster. So it's the same name I provided when I created the cluster. I need to supply the region, which is the region I placed the cluster in. And I need to supply the project ID, which is the project ID we've created. And after I do this, my kubectl is communicating with the newly created cluster, and I can do get pods or see the nodes I have. Let's see if this works. No pods, but if I do get nodes, I have a few nodes that are open and running in my cluster. So great, this command is now communicating with my cluster. We can now take this cluster and take our infrastructure as code project and install using Tofu, Terraform, install Flux in our cluster. So the last thing that I want to show in this lesson is that we have the power using our infrastructure as code technology. We have the power to install on stuff on our Kubernetes cluster. And what we're going to do is we're going to install Flux on our cluster using the Flux Provider. So we are basing our GitHub repository, the course GitHub repository, we're going to place all the infrastructure as code in the GitHub repository so we can actually see what cloud resources we are using. And it's important to define your infrastructure as code. This is why we're dedicating a few lessons outside of Kubernetes to focus on infrastructure as code, because it's really important it's a key concept that you have to understand in order to understand the course repository. So we're going to use the Flux Provider to install Flux on our cluster. There are a few advantages of installing Flux on our cluster this way. We're going to talk on the next slide about those advantages. But for us to install Flux on our cluster, we need to use a provider called the Flux Provider. Using this, we can install Flux on our cluster. So what it does, it will give Tofu, enhance the power of Tofu, and then Tofu will be able to install Flux on our cluster. Now, of course, to configure Flux, to have Tofu install Flux on our cluster, we have to configure the Flux Provider. So to configure the Flux Provider, we need to configure it to talk with our managed Kubernetes cluster. And we also need to configure Flux Provider to talk to our repository, to our GitHub repository. So these are the configuration. They're built from one section to configure Flux, to configure the Flux Provider to talk to our cluster, and another section to configure the Flux Provider to talk to our GitHub repository. And there's a few advantages of installing Flux this way, especially when your organization grows, when your app grows, when your startup grows. You usually are going to work with more than one cluster. You might have cluster for production, staging, dev. You might have cluster for your CI. You might have clusters arranged by teams. So usually as the company grows, they're not working with a single cluster. Now it might be okay to install Flux with the Flux CLI, like we saw in the first lesson, if you have a single cluster. But if you have many clusters and you want them in terms of the basic thing in those clusters to be similar and to be declarative, you want all those clusters to run Flux in a certain version, to run certain components of Flux. It's best to declare it to install Flux declaratively by writing infrastructure as code. So the installation, one advantage is the installation is declarative, including the version you specify in that declarative installation. You specify the version of Flux that you want to install. It's easier to install in multiple clusters, and also it's easier to update. Whenever there's a new version of Flux, you want to update Flux, but you want to also update it in all the cluster that you have. So it makes things easy when they're declarative, easy to update as well. And it's also additional, it's easier to extend Flux. If Flux has new components that you want to add, it's also declarative and very easy to do in all your cluster. Now we have to authenticate our infrastructure as code with Kubernetes. As we said, to configure Flux Provider, one thing you need to authenticate it with Git, one hand you need to authenticate it with Kubernetes. To authenticate with your managed Kubernetes, it's best to the authentication to be declarative. You don't want that authentication. There are different ways where you can authenticate Tofu with your cluster. For example, you might say, Tofu, just use my kubectl to authenticate. But this is a problem. What if you have multiple clusters that you're managing? It's going to be hard that it's just using the kubectl instead of being declarative. So prefer the authentication to be declarative. And declarative, I mean, how do I authenticate and to which cluster? Those two data should be declarative. It's better to authenticate using a short-lived token, and it's better to use some kind of exec plugin. So the Flux Provider is using, behind the scene, is using the Kubernetes provider. The Kubernetes provider has a means to authenticate using something called exec plugin. Exec plugin is like a CLI command that will be executed in order to obtain short-lived token. And the cloud providers, they provide a CLI command either with their default CLI or by maybe extending that CLI like GCP is doing. So it's better to use the cloud provider CLI. In our case, GCP, the cloud provider is gcloud, to get short-lived token and connect that cloud provider CLI for getting short-lived token connected to the exec plugin. This way, everything is declarative, and every time you run your code, Tofu will generate a short-lived token using the cloud provider CLI and then use that token to authenticate with your cluster. Now in gcloud, the command to install that CLI command that allows you to obtain a short-lived token is a component called gcloud auth plugin. So you have to run this command in order to obtain the CLI that you then connect to the exec plugin to create that short-lived token. What we're going to do now is define the Flux Provider and the required providers that Tofu will know that it requires to install the Flux Provider in the right version. We're going to configure the Flux Provider. Configuring means configure Flux Provider to authenticate with our Kubernetes cluster, and configure the Flux Provider to authenticate with our Git repository. And we're also going to install Flux on our new cluster. So what we're going to do is we're going to back to our code, and we're going to the providers. And in the providers, we are going to say that one of the required providers is Flux. And it has to be a version which is the latest version of Flux. Well, the latest version of Flux is 1.4. So we'll tie it to 1.4. Great. Sorry, 1.4. Now, let's go to the main TF file, and in here provide a configuration for the Flux Provider. Now the Flux Provider, we can check the documentation. The Flux Provider requires configuration to authenticate with Kubernetes. So this is under the key of Kubernetes here. So we'll go and specify Kubernetes. Then in here we need a few things. We're going to need what we're going to authenticate is using exec plugin. So we're not going to provide client certificate and client key. This is another way of authenticating by creating those certificate and key. But it's better to authenticate with the gcloud, with the cloud provider CLI, using a short-lived authentication token. So I'm going to provide host and cluster CA certificate. Host is we can take the host as from the module GKE, so I can open Tofu console, and the host is model GKE endpoint. And the cluster CA certificate, we can also obtain it from the module GKE that we created. So this is base 64 model GKE cluster CA certificate. I'm not sure if it's cluster CA certificate. I think I'm using Tofu console, and it's called CA certificate. And we're going to use exec plugin to authenticate. And the exact plugin, let's see if they have an example here. The exact plugin needs an API version, and it will need the command to run. Now this command varies depending on which cloud provider you are using. So cloud providers provide you CLI to obtain short-lived authentication token. You provide a command in args. In AWS it will look like this, EKS get token. For GCP it will look a bit different. For GCP we're going to use a plugin, gcloud component, a gcloud component called that is not by default installed. You have to run the gcloud components install command called gke gcloud auth plugin. You have to run this install command. If it's installed correctly, you should see it as a CLI, so you can do -- version. So this is our command here. So this is how we're going to authenticate with our Kubernetes cluster. And also we need to provide configuration for authenticating with Git. So for this, we're going to copy this. We're going to say that we're authenticating with Git in our course repository, which is this address here. And our course repository is this, Academy's Kubernetes Flux. Don't forget to start. So I'm going to use this means of authentication, and for authenticating with for authenticating we need to provide username, and we need to provide our personal access token. GitHub, let's call it personal access token. And this is the same way that we showed in the first lesson how to obtain personal access token to your repository. So I'll place this, and I'll also place it in the variables files. I'll create a variable GitHub personal access token, description, the token used to talk to our GitHub repo, and it's a type of string. Okay, great. So this is the configuration for Flux. What I will do now is I will create a GitHub personal access token like we did in the first lesson, and I'm going to provide it in the Terraform TF-vars file as the value of this variable, and then we'll see if Flux can talk with our Kubernetes and with our GitHub repository. Okay, so I provided the GitHub personal access token in the file Terraform TF-vars. Now let's create our resource for bootstrapping Flux. Maybe I'll have yours. It starts with Flux. Okay, so let's see, check the documentation. So they have a few examples here. So I can, the resource name is Flux Bootstrap Kit. So it's Flux Bootstrap Kit. And I need to name it. So let's say it's Flux Test Cluster. Now, a few things that it will require. It requires a path. And the path, we will check our GitHub repository. And we're placing the clusters in the clusters directory. And so let's create a clusters test or clusters prod. Let's create clusters prod. Okay, and I can also specify the components that I want to install. Let's see different flags that we have here. There are a few options. I can specify the components that I want Flux to install, but let's keep it as the default one. I want source control, customized control, helm control, and notification control. And I think this is the only thing that we want to change, the path. So okay, let's try to run this code and see if the Flux Provider is managing to create Flux on our cluster. So I'll create, first I need to tofu init, right? Because we are installing a provider. Failed to query available. It might need that we need to specify the Flux here, the source of Flux here. So let's go to the documentation of the Flux Provider. So Flux, we need to specify the source here like they did here. It's not the default source for HashiCorp like our other provider, like our Google provider. So in here, it's a provider that Flux created, so it's located in their location. So we need to specify the source here as well. Now let's do a tofu init again. It's installing Flux, and it successfully installed Flux version 1.4. Great. So let's do a tofu plan. So I have, okay, let's do it from here. I have the TF state locked because I have tofu console open in another tab. So I'll do tofu plan again after exiting the tofu console. So it has one to add, but which looks great. It's going to install the components, those 4 components, and in the path clusters prod. So let's try to run this, tofu apply. The version of Flux that will be installed is the latest, is 2.4 at the time of this recording. Let's enter yes to install. Hopefully it will run without any errors, but let's wait and see. Should take a while. In the meantime, we can go to their GitHub repository. We'll notice that we currently only have cluster staging. If everything worked correctly, we should have a clusters prod because we use the path clusters prod. So let's see I already see a cluster prod, which is great. We didn't have this before. It means the Flux provider can talk with our GitHub repository. Hopefully it can also talk with our Kubernetes, and then there are no problems there. There should be no problem with the installation. Great, awesome. We have install Flux in our cluster. And just to verify that we did install Flux in our cluster, we can do kubectl get pods in the namespace Flux system. If all worked correctly, we should see the Flux pods are running. Awesome. So we have the Helm controller, the customized controller, the notification controller, and source controller all are running. So we managed to use infrastructure as code. In this example, we used OpenTofu, but the same applies to Terraform, to create a GCP project, create a network, create a managed Kubernetes cluster, and install Flux on that cluster. Great, so we finished with the lesson of installing Flux using infrastructure as code. In fact, I can go back to my code, and now that everything is done, I can do a tofu destroy just to destroy all the resources that I created. So everything in this course is declarative. So you can create those resources and work a bit on this course and the exercises and code a bit and then destroy it. So everything, including the cloud resources and the Kubernetes resources, everything will be declarative. So it's easy to just create and destroy, and it will save you a lot of money in the process. So I'm destroying everything that we created in this lesson. I think something that is important to mention in this lesson, the importance was to show that it is possible to install Flux using infrastructure as code. It is possible and important to create cloud resources using infrastructure as code. A lot of the things here, we did not follow best practices. Next lesson, we will focus on best practices with placing your state inside a bucket and using TerraGrunt and saving repeating code and creating environment. We will focus on how to create environment in production, how to create environment in staging how to save money in production, what is a must-have configuration for high level availability. So our next lesson will also focus on infrastructure, but we'll take it one step further. As usual, everything that we touched here in this lesson everything, including the source code, including a step-by-step guide, the video, everything is available in Academy's website. I'll place the link in the description. We will really appreciate if you star Academies. So everything is open source, non-profit. So if you like the content, if you like the open source knowledge sharing, community driven, make sure to click our GitHub and star it. Also make sure to star our course repository. I'll place a link for that as well. So just to summarize everything, we will work in this course with a cloud provider. We will work with GCP, but if you raise an issue in the course repository, we'll show example of other cloud providers as well. And it is important to practice on cloud provider because a lot of the things that we're creating in our Kubernetes cluster using Flux are also affecting our cloud configuration. So we need to really understand also the infrastructure as code and the cloud provider in order to work with Kubernetes in advanced courses. So our infrastructure has to be defined in infrastructure as code technology. Now, we're not advocating for a certain technology. We will show you in this course with Terraform OpenTofu, but feel free to raise an issue when we show example of other infrastructure as well. The focus is on not on the infrastructure as code technology, more on the concepts and the examples that were given here, not necessarily the code. During this course, our default is to focus on infrastructure as code using OpenTofu. The same code can work with Terraform as well. Flux installation, remember that Flux installation can be, we can install Flux using infrastructure as code technology. If you have more than one cluster, you should definitely install Flux using infrastructure as code and not using the Flux CLI. That's it. Thank you for listening, and I will see you in the next lesson.